Hi there, my name is Brendan. This is my channel Alpine Bravo for all things Microsoft Flight Simulator. In this video, this is a continuation of my series of tutorials on the Learjet 35A by FlySimware, and this will be looking at the electrical systems used by this aircraft. The electrical system on the Learjet 35A can be quite complicated. However, in this tutorial, I'll just focus on the key aspects of it that give you an overview of how it works, but also just focus on the systems that are actually simulated in this model. The aircraft requires both direct current and alternating current sources of supply to function, and some systems need AC, some need DC, some need both. So that's an important thing to understand from the outset, but what I'll cover in the rest of the tutorial is what the sources of electrical supply are, how it's distributed, how it's controlled, how the systems are protected, and how this function of the system is indicated and how you monitor it. So the process starts with understanding the sources of electrical supply. The primary source of supply for electrical power for the aircraft are two DC generators, one on each engine. These also function as the starter for each engine as well, but their primary function, as I say, is to provide DC electrical supply. There are two lead acid batteries in the tail cone that also provide DC electrical supply. And the alternating current supply for the aircraft comes from two solid-state static inverters also in the tail cone, and those are entirely electronic components that take the DC supply from the generator or the battery and convert it into an AC electrical current. Well, there are two other sources of supply. There's the ground power unit that will supply the electrical needs of the aircraft as well. And the very final source of supply that you can have if all else is failed is there is a single emergency battery that will provide supply to some of the most basic and essential systems like the standby flight instruments and the electrical circuitry for the landing gear and the flaps. If we turn to distribution now, it is quite complicated. It is arranged through a number of electrical buses for both the DC supply and the AC supply. And if we look at this diagram here, that gives you an idea of the arrangement. I'm not going to try to explain all of that. I'll just point out though, you've got for the batteries, there's a battery bus for each battery, and those are hot. That is to say, anything that's on the battery bus is connected directly to the battery. And that includes things like the motor for the cabin door. So it means that you don't need to have the battery switches in the aircraft turned on for these systems to access electrical supply from the battery. So they're hot. And that's so you can open the door without or close the door without having to be in the cockpit. However, any system that is hot and draws current directly from the battery has to be turned off. Otherwise, it will drain the battery when you leave the aircraft overnight. I think cabin lights are the door motor and the cabin lights are the two main things that are connected directly to the battery bus. Then the next, well, you've got then a battery charging bus, which will receive both generator power, battery power, and ground power. And from that, there are a number of systems that come off that. And there's a generator bus that comes off it, and then another bus that comes off the generator bus, which is the power bus. mirrored on each side, and then there's an essential bus, two essential buses actually, on each side, so 4 in total, and then a main bus as well, and those are just the DC ones, and then you have AC buses as well. There are 2 buses on each side. AC buses is 115 amp, 115 volt, and a 26 volt bus for different AC systems. So pretty complicated all in all. However, you don't really need to worry about that more than that. How are these systems protected? They're protected through the circuit breakers on the left and right side walls of the cabin. So there's the circuit breakers for the pilot side sidewall, and then there are the circuit breakers for the co-pilot side. There is another form of protection as well, which is there are a series of current limiters, which act as a form of slow trigger fuse, and they are in the tail cone. They're not something that pilots can access in flight, and if a current limiter blows, it has to be serviced on the ground. And the purpose of the current limiters is to prevent a cascading electrical failure occurring. So if you have one system shorts and fuses and causes a spike in current, that could, through those complicated network of buses that you saw, that could cascade a series of electrical faults down through the aircraft. But the current limiters should prevent that and isolate the fault. If a current limiter is to fail, now, you won't necessarily know that if it's one of the minor current limiters. However, they're not modeled in the aircraft, but there are 2 important current limiters, one for each generator. And if one of those is to fail, then you would get an annunciator on here. I'll just show that once I've got the aircraft powered up. Is worth saying that neither the current limiters or the circuit breakers are modeled in the aircraft, so be aware of it, but it's not something that you're going to have to deal with. And finally, the only 2 systems that you can't operate just from the battery are the air conditioning unit and the auxiliary heating unit if it's installed in this aircraft. But the air conditioning unit is this controlled over here. That basically, those 2 systems have such a heavy amperage draw that there's a protection that means you can't turn them on unless you've got a generator running or GPU connected. They won't operate off the battery. And also the battery itself, if it's below 13 volts, you won't be able to turn it on as well. It's not modeled, but in reality, yes, a very low voltage state in the battery again. As a sensor would detect that it's below 13 volts, or is it 13 or 16? Anyway, a low voltage state, and it just won't complete the circuit if that's the case. And it's a protection. It's a way of making sure that you don't try and operate the aircraft with insufficient charge in one of the batteries. So how do you monitor the electrical system? That's through a series of dials on the main panel. We'll just zoom in and you'll be able to see those. And so it's this little panel here, and we have DC volts, AC volts, amps, and now it's oil temperature. So just to explain, DC volts will show the voltage from the current main source of supply, be that the battery, the generator, or the ground power unit. AC volts will show the output of the inverters or an inverter. And just to point out, so that's that dial there, whether that dial there is monitoring the primary inverter or the secondary inverter is controlled by this switch here, AC bus primary and secondary. So that switch just all that does is control where the voltmeter, the AC voltmeter, is reading. And that's a way of seeing whether an inverter, a particular inverter, is functioning as expected or not. The 2 amps, that's left generator, right generator, and that will show the current load on each generator. And each generator, as you can see, can rate it up to 400 amps each, but if anything over 100 amps on each generator, and you would be a bit concerned. So those are all the elements of the system. How do you use it and what do the things look like in practice? Well, first of all, the battery itself, itself will provide electrical power for the aircraft for about 30 minutes, which is normally sufficient for all ground operations. But if you're going to be on the ground for an extended period of time, then you will want to use a ground power unit, and that can be connected in the tablet. You can see the tablet has its own battery. It doesn't need any supply. You can just toggle the ground power unit there, and that will connect the ground power unit, as we can see there. There is significant redundancy in the electrical system. If you were to lose, well, each generator can provide all the electrical needs of the aircraft on its own. Likewise, each battery can provide all the electrical needs of the aircraft on its own, although for a limited time, and each inverter can provide all the AC electrical needs on its own as well. I mean, the inverters are solid state. They are not items that fail very often. And then, as I said in the intro, you've got the emergency battery if all else has failed. So to power up the aircraft, you turn the battery on, and you'll see that some dials and instruments have become alive. They're the ones that rely just on DC power. And if we come over and we look at the DC volts, that is now indicating, and it's indicating about 28 volts. And that is because there is a ground power unit connected. So whenever the GPU is connected or generator is running, you'll get 28 volts showing there. However, if I turn the GPU off, and we'll now see that the DC volts has dropped to, well, it's about 25. And that's a good way of telling if your aircraft is relying just on battery power or whether you've got a generator online. So for example, if a current limiter was to fail, and now that we have aircraft power, I can show you current limiter. So if I turn that on, and if we look, so on the top row of the annunciators on the far left, you'll see cur lim in red. And if that illuminates, that means one or both of the generator current limiters has failed. And the only way you can tell whether it's one or both is by monitoring the DC volts. If it's reading 28, then you know it's 1. If it's reading 25 or less, then you know both current limiters have failed and you're just on battery power. And unlike a generator trip, you will not be able to reset that. You will not be able to get your generators back online. The inverters provide AC power, and as already noted, they will take DC either from the generator or from the battery. So that allows you to turn an inverter on without having a generator running, because a generator needs an engine to be up and running. And you can see that the avionics, a bunch of instruments started to come on there. You had the main attitude indicator now got the power it needed. And if we come across here now, we can see AC volts are being supplied, 115 by the inverter. So I've only turned on the primary inverter at the moment. As I mentioned before, this switch here controls the voltmeter. So because I've only got the primary inverter on, if I put that into secondary and come back here, now AC volts are still showing 115. Now there is a cross connection that exists between the two inverters, meaning that if one is offline, that the other will operate. But my understanding was that that should be reading 0 there. So I'm not quite sure what's happening with that. I've already mentioned that there's an emergency battery as well, and you'll see that feature in the checklists. The emergency battery is controlled by this switch here, which is a 3-position switch. So it can be off, on standby, or fully on. I'll put it fully on now. And if you listen carefully, you will start to hear a whine, and that is the standby gyro spinning up. You'll also see in the checklist mention of looking for the emergency battery indication light. Now, if you can't find it, don't worry, you're not going crazy. It should be in the panel around about here, but I don't think it's been modeled. So don't go crazy looking for it. If it is somewhere else in the cockpit and I've missed it, please let me know, but I've looked high and low for it and I cannot find it. So the emergency battery, as I say, has 3 positions, fully on standby, or off. So emergency battery will, when it's fully on, will provide electrical power for the standby flight instruments, for the electrical operate switches that operate the gear and the flaps. If, however, you put it in standby, it will only provide emergency electrical supply, if required, for the standby flight instruments. And that extends the life of the standby battery considerably. So say that you had an electrical failure at high altitude and you needed to get down and everything's gone. You basically, I mean, if you're on the standby battery, it means you've got no generators, and that probably means you've got no engines. So you're gliding down, looking for the nearest available field that you can land at. You would put the emergency battery into standby for most of that descent to preserve it and make sure you had enough juice in that emergency battery to operate the gear and flap switches, electrical circuits, when you are coming in for your landing. So that's the emergency battery functions. I'll start an engine now, and you can see the generators in operation. So I've started engine number 1 on the left now, and we'll just talk about what's going on with the generators. So DC volts are still showing 25, and that's a good indication that I'm on the battery. I've also got the left and right generator caution lights showing as well. AC volts, well, they're being provided by the inverter, so that's fine. But we've got 0 amps on either side, so that shows you that also that neither generator is taking any load, and that's not surprising because I've not turned them on. So we've got engine number 1 started. I'll take that switch out to start position and put it into left generator, and we come back up here, and now we can see that on the left we've got a load of about 50 amps showing, and our DC volts have now gone up to 28, which shows you that the system, the DC system, is being provided by the generator, and our left generator caution light has extinguished. Exactly the same for the right engine and the right generator. The only thing I would finally note is that when starting the aircraft from the GPU, which you can do, make sure to disconnect the GPU before bringing either generator online. We've got the left generator and right generator reset switches. They are currently not modeled, but in reality you would use if you had a generator trip. Then you would be using those to reset the generator to bring it back online. So just by way of conclusion, the system, the electrical system is modeled to reasonable depth. You will see the correct voltages depending on the state, and you'll also see the load, the amperage load changing depending on what aircraft systems that you've got on and running. The Yeah, I mean, the circuit breaker is obviously not modeled, although without the associated kind of systems failures, I don't really see a lot of point in modeling circuit breakers unless you've actually got system failures associated with them as well. Okay, that's about everything for electricals in the Learjet 35A. Thanks for watching.